the group reporter for group 3 on the Rankine cycle. A little overview of the Rankine cycle. It's used in a lot of power production, nuclear, coal. It's more efficient than other cycles because it's closed loop. You have hot water feeding into your boiler. It requires less heat to keep it hot, create the gas to operate the turbine. You got your saturation line right here with your pump being over here, increasing pressure. Then you have your boilers, this top line. It has constant pressure heating. And then you have your turbine 3 to 4 where you get your workout and create electricity. And then your condenser 4 to 1, constant pressure. Alright, these are going to be all my graphs that I made from the data on different values we use for calculations. This one's the fuel flow. As you can see from most of this experiment, it was constant because we didn't adjust the valve throughout it. And then you can see at the end where we turned the valve off and it was going down. As you see throughout all these graphs, I needed to pick a steady state point where everything was pretty constant. And I picked 250 seconds. That's what the line represents. You'll see that on all the charts. We have information on our boiler right here. This is the temperature of our boiler as time goes on. The temperature decreases because the pressure was constantly decreasing throughout the experiment. It's tough to keep the pressure even for the experiment because you have to keep adjusting the valve and it throws off your values. So we kick a steady decline, and you can see that right here. This is information on our turbine. You have your inlet and outlet temperatures. Inlet at top, outlet on bottom. The temperature going into the turbine is a lot higher than the temperature coming out, which is kind of surprising because it's a very small device. So in such a small distance, that's the temperature drop. Same with the pressure. Huge pressure drop in the turbine from the inlet to the outlet. This is information off the generator, current in amps and current in volts. They're very closely related, as you can see. You can also see where the steady state was, why I picked it. This was one of the reasons right here. It was kind of sporadic towards the ending and kind of sporadic towards the end, but somewhere in the middle there you have nice little steady state conditions. At the steady state conditions, these are all the values that I pulled. You have your atmospheric pressure is 101 kilopascals. We had the volume of water in. We used 4.5 liters, added it to the boiler before we started the experiment. Looking at the view tube on the boiler, the tube went down, and calculating that difference in volume in the boiler, I found that we used 2.79 liters of water throughout the experiment. The fuel flow was pretty steady, 4.41 to 4.42 liters per minute. Pressure in the boiler was 683 kilopascals. Pressure for the turbine going in was 169 kilopascals. The pressure for the turbine going out was 23.7 kilopascals. The temperature for the turbine going in was 130.4 degrees Celsius, and the temperature coming out was 105.5 degrees Celsius. When we drained the condenser, we found that we had 0.55 liters of condensed fluid. Boiler and the liquid propane flow. The calculated heat flow out of the boiler was 6 kilowatts. The heat of combustion from liquid propane calculated to be 0.315 kilowatts. These don't add up, and I'm assuming it's because I only know the water going through the system for the entirety of the experiment, which includes the not steady state conditions, but a lot of the math was done for the steady state conditions. So that is what I think was the discrepancy. For the turbine and generator, the power generated by the turbine was 13.26 watts calculated, but the power generated by the turbine was only 7.439 watts. The efficiency of the generator calculated ended up being 56%. The fluid going in and coming out of the turbine was superheated. For the condenser, we had a heat rate flow leaving the condenser at 6.03 kilowatts, and efficiency of the condenser calculated to be 8.26%. I believe that this is because the condensed water was not being fed into the boiler per a typical Rankine cycle in this particular experiment. And then the cycle efficiency ended up calculating out to be 4%. That is all. Any questions?